In the last few years, artificial intelligence has made incredible progress in understanding and generating human language. This has led to a number of exciting applications, such as natural language processing, NLP, in chatbots, text-to-speech, TTS, systems and machine translation. Natural language processing, NLP, is a subfield of linguistics, computer science, information engineering, and artificial intelligence. NLP focuses on the interactions between computers and human languages. It can use deep learning algorithms and speech recognition to detect patterns in language. Python and the Natural Language Toolkit, NLTK. The Python programming language provides a wide range of tools and libraries for attacking specific NLP tasks. Many of these are found in the Natural Language Toolkit, or NLTK, an open-source collection of libraries, programs, and education resources for building NLP programs. The NLTK includes libraries for many of the NLP tasks, plus libraries for subtasks, such as sentence parsing, word segmentation, stemming and lemmatization, and tokenization. The earliest NLP applications were hand-coded, rules-based systems that could perform certain NLP tasks, but couldn't easily scale to accommodate a seemingly endless stream of exceptions or the increasing volumes of text and voice data. Enter statistical NLP, which combines computer algorithms with machine learning and deep learning models to automatically extract, classify, and label elements of text and voice data, and then assign a statistical likelihood to each possible meaning of those elements. Today, deep learning models and learning techniques based on convolutional neural networks, CNNs, and recurrent neural networks, RNNs, enable NLP systems that learn as they work and extract ever more accurate meaning from huge volumes of raw, unstructured, and unlabeled text and voice datasets. Natural language processing is the driving force behind machine intelligence in many modern real-world applications. Here are a few examples. Spam detection. You may not think of spam detection as an NLP solution, but the best spam detection technologies use NLP's text classification capabilities to scan emails for language that often indicates spam or phishing. These indicators can include overuse of financial terms, characteristic bad grammar, threatening language, inappropriate urgency, misspelled company names, and more. Spam detection is one of a handful of NLP problems that experts consider mostly solved, although you may argue that this doesn't match your email experience. Machine translation. Google Translate is an example of widely available NLP technology at work. Truly useful machine translation involves more than replacing words in one language with words of another. Effective translation has to capture accurately the meaning and tone of the input language and translate it to text with the same meaning and desired impact in the output language. Machine translation tools are making good progress in terms of accuracy. A great way to test any machine translation tool is to translate text to one language and then back to the original. An oft-cited classic example. Not long ago, translating "the spirit is willing but the flesh is weak" from English to Russian and back yielded "the vodka is good but the meat is rotten." Today, the result is "the spirit desires but the flesh is weak," which isn't perfect, but inspires much more confidence in the English to Russian translation. Virtual agents and chatbots. Virtual agents such as Apple's Siri and Amazon's Alexa use speech recognition to recognize patterns in voice commands and natural language generation to respond with appropriate action or helpful comments. Chatbots perform the same magic in response to typed text entries. The word natural relates to humans, as opposed to artificial or machine languages that are used by developers. Natural language understanding, NLU, is the first step necessary to achieve natural language processing, because NLU is in fact the science of deducing an intention, intent, and related information, entity, from natural conversations with information extraction. NLU is broken down into three linguistic levels: syntax, semantics, and pragmatics, understanding the entities and intents. At a basic level, AI algorithms process language by breaking it down into its component parts. This process is known as natural language understanding, NLU. The algorithms then analyze the language to determine its meaning and intent. For example, a chatbot might use NLU to understand a user's question and generate an appropriate response. In addition to understanding language, AI can also generate human language. This process is known as natural language generation, NLG. NLG systems use AI algorithms to generate written or spoken text from scratch based on input data. For example, a NLG system might generate a description of an image or generate a personalized message for a customer. The role of entities in natural language processing, NLP, is to collect specific pieces of information from the user during the conversation with the virtual agent. With this automatic speech recognition, a conversational AI can understand the user's intent and its context to determine the best answer to a request. Thousands of entities related to its service desk and the digital workplace. The following approaches for identifying entities in the user utterance. Named Entity Recognition, NER, based on machine learning. NER based on an ontology of entities, a formal description of knowledge as a set of concepts within a domain and the relationships that hold between them. And NER based on grammar rules. Understanding human interactions lies in this ability to identify the intention of the user, extract useful information from their utterance, and map them to relevant actions or tasks. NLU model that enables our virtual agent to detect a user intents and entities with a very high accuracy thanks to semantic analysis. As a result, the virtual agent will match the user's intent with the most relevant knowledge available in its knowledge bases, or FAQs, or any enterprise content it has been allowed to access. The virtual agent's accuracy will also improve and integrate new knowledge with past conversations with users thanks to machine learning algorithms and learning models. AI has made incredible progress in understanding and generating human language, but it still has a long way to go. AI systems are still limited in their ability to interpret context and understand subtle nuances in language. However, as AI continues to advance, it is likely that these systems will become more and more capable of understanding and generating human language. What do you think about artificial intelligence, and how can it renovate our society? Share your thoughts in comments below. Also, don't forget to like this video and share it with your family and friends. Make sure to subscribe to our channel and press the bell icon for watching more videos in future.